There are a couple of different methods for drawing rectangles in SketchUp. In the first method, you start drawing and then type in dimensions, and SketchUp will complete the rectangle for you. And this is very much like AutoCAD. I'll start drawing a rectangle at the origin point, and then I'll type in two values. Rectangles are two-dimensional, so we have to separate the length from the width, and it depends on the language that you're using. In English, we separate values with the comma. So I'll type in 12 feet, comma, 20 feet, and press Return or the Enter key on the PC. In SketchUp, you can keep your values positive, unlike in AutoCAD. So for example, let's say I'm drawing a rectangle over this way. If I was in AutoCAD, I would have to type in negative 12 feet, comma, negative 20 feet, because I'm going in the negative red and negative green directions. In SketchUp, that results in a rectangle over here on the other side. The negative values in SketchUp mean to go in the opposite direction from where your cursor is. So generally, we don't even have to worry about sign in SketchUp. We can just draw a rectangle over this way, and we can just say 12 feet, comma, 20 feet, and the rectangle goes in that direction. Of course, SketchUp also uses a relative coordinate system, so you don't have to start everything from the origin point. You can start at any arbitrary point and type in values, and they will work relative to the point that you started from. There's another method for drawing rectangles that I favor over this AutoCAD style approach, and that is simply to draw a rectangle at some arbitrary size. It doesn't really matter. And then immediately afterward, go back and type in values to dimension it. I'll type 12 feet, comma 20 feet, and the rectangle is resized accordingly. If I mix up the length and the width, which I often do, I'll just reverse the numbers and type them in again. 20 feet, comma 12 feet. Unlike lines, arcs, and circles, with rectangles you don't have the ability after you create the object to go back in Entity Info and set anything about it. So for example, I can select this face and I can see the area, but if I change this to 300 square feet, it won't let me do it. It's not possible to affect the form by changing the number here. Similarly, I can select everything and then deselect the face so that I just have the edges selected, and now I can see the perimeter length of those edges, but I don't have the ability to change it. So you only have one opportunity to dimension a rectangle, and that's immediately after you create it. There are two different guides that are built into rectangles. The first is the square guide, and you just have to move your cursor around until you see this highlight, and then you can be assured that you're going to be drawing a square. You don't hold down the Shift key as you might in Adobe applications. You just have to move the cursor around until this pops onto the screen. If I click there, I can be assured that I have a square. Similarly, you can also work with the golden section. You just have to move it more over in this proportion, and you'll see the golden section, which is a proportion that's been known for thousands of years. The golden section is considered to be the most aesthetically pleasing proportion in existence, and it's related to the Fibonacci numbers. There's a plugin that's been written by Rick Wilson of Smustard called Golden Gauge, and it's related to the golden section. It uses Fibonacci numbers to create a component that's scaled when you insert it into SketchUp. And it works like this. You go to the Plugins menu and choose Golden Gauge. Read the status line down here to see what's happening. It says select first end, select width, and then select height. This golden gauge is meant to work in elevation. When I click the height, it inserts this component, which is automatically sized according to the points that I click. Now I can use the golden gauge to help me proportion an elevation. Just like with rectangles, there are two methods for drawing circles, and the first is what I call an AutoCAD style approach, where we set the center point of the circle first, and then after that we type in a dimension. I'll type in 25 feet and press Return. SketchUp completes the circle for us. On the other hand, we can draw a circle of some arbitrary size just to get it on the screen, and then immediately afterward we can type in a value and SketchUp will resize the circle. Unlike with rectangles, you can select the edge of a circle, go to Entity Info, and you can set the radius value here at some later date. I can make this say 30 feet, and the circle is resized. You can set the number of segments here or in the Measurements toolbar while you're drawing. I'll draw a circle. I'll set its size to 25 feet, And then I'll type in the number of segments right in the measurements toolbar. I'll type 12s. That sets the number of segments. Now we have a 12-sided polygon. All curves in SketchUp ultimately are reduced to a discrete number of straight-line segments. You might say, well, if that's the case, why don't we just create a circle that has 120 segments? I'll do that. I'll type in 120s. And for all intents and purposes, this curve is perfectly round. However, we run into problems later if we push-pull this up to create a cylinder, and if we make this a handrail and follow it along a path, we're going to have an inordinate number of polygons in our model, and the performance of SketchUp is really going to suffer. It's very important that you balance the need for smooth curves with the need to be efficient when you're modeling. And so you just want to have as few segments as possible to convey the idea of a smooth curve. So for a circle, 32 is a good number. It depends on the scale that you're looking at it, though. If you're creating a rotunda that's round, you might need more segments. If you're creating a profile for a handrail, you might get away with 8 segments or 16, something of that magnitude. The difference between a circle and a polygon is very subtle. Let's take a circle, for example, and give it 6 segments. So it's actually a hexagon. I'll push-pull this up, and you'll see that the edges appear smoothed. We don't see a sharp division there, even though it's actually a hexagon. If we make a polygon with the same number of sides and push-pull it up, it has sharp creases here because the edges are not smoothed, nor are they softened. We can smooth and soften these edges manually by using the eraser tool with the Option key held down. So it's possible to convert a polygon into a circle, but it's really not necessary. It's nice to have specialized tools for these jobs. Circles have handles on their quadrant points, which allow you to resize them. I'll draw a circle over here, and I'll switch to the Move tool. If I grab the circle from some arbitrary point along the edge, I can just move it. If I grab the circle from one of its quadrant points, these are the 4 cardinal points, like north, south, east, and west. And they line up with these endpoints here. They're not on midpoints. If I grab it from a quadrant point, I can then resize the circle. And that works on all 4 quadrants. Sometimes it's tricky to figure out which one is the quadrant point, and it's helpful to look in a top view so you can more easily locate those points. This also works when you have a cylinder. You can grab the quadrant point and resize the cylinder. I might have better luck if I look at it from the top view. I can then make a cone in this fashion. Your point of view determines which plane you draw in. Most of the time you'll be drawing in the red-green plane. You can think of that as the ground plane. When I draw a circle, it appears down here. Notice that the circle is blue. That means that the axis is aligned with the blue axis, the vertical axis. If, however, I rotate my point of view and I try to draw a circle, it might appear in a different color. Here we have a red circle, indicating that its axis aligns with the red axis. If I change my point of view again, there'll be some point where the circle will turn green. This will allow me to draw an orthogonal circle to that red one. So now we have a green circle, a red circle, and a blue circle. There's another way you can effectively reorient the drawing plane without having to change your point of view. And it works like this. Draw a rectangle off to the side someplace, and push-pull it up. Now you have 3 reference surfaces that you can use to lock inferences. For example, I'll draw a circle, and I'll hover it over this surface. While I'm there, I'll hold down the Shift key to lock that as an inference. Then I can come over here and draw a circle. In the same way, I'll go over this surface, hold down the Shift key to lock that as an inference, and I'll draw another circle. Finally, I can lock the ground plane as an inference, and then I can draw a third circle. Push-pull is really a revolutionary command. Don't get me wrong, every 3D program has the ability to extrude, but push-pull makes this process of going from 2D to 3D so easy and so intuitive that it makes SketchUp a joy to use. I'll push-pull this box up simply by pressing P to activate the tool, and I'll click on the surface, and then click again to set the height. As with the rectangle and circle tools, there are two ways to push-pull. You can either click to start push-pulling and then type in a height, or you can click and push and pull and then type in a height afterwards. There's also an option to create new geometry when you push and pull. I'll click to start pushing and pulling, and then I'll press the Option key on the Mac. This would be the Control key on the PC. There's actually a bug in the Mac version which references the PC shortcut right here. It's actually the Option key on the Mac. In any case, when I do this, the original geometry right here on this ring is left behind. I'll do that on the box as well. I'll click to start the operation, press the Option key to leave the original geometry behind. This gives me the ability to separate faces, and now I can push and pull these independently. Push-pull is the tool for turning plans into buildings. I'll push-pull this surface up and type in 8 feet to set the ceiling height. Next, I'll push-pull this wall up and match the height by clicking a point along the top edge of this wall. That way I can avoid having to type in 8 feet every time. An even faster way is simply to double-click on a surface, and that will push-pull up to the last value that was used. So in this way, I can quickly create some architecture from a series of surfaces in plan. The one limitation of push-pull is that it doesn't work on curved surfaces. Take these two surfaces for example. There's actually no problem with push-pull at this point. I can push-pull these things up, and they do self-intersect, but that's not really a problem. I can go in with the eraser tool and erase these surfaces, and I can heal this by drawing a line across here. The problem comes when your surfaces have any smoothed or softened edges. I'll use the eraser tool here and hold down the Option key to smooth that surface. Now there's no longer a shading change here. It appears like it's one curved surface. But if that's the case, I can no longer push-pull it. I get this circle with the line through it, indicating that it's not possible to push and pull that up.